Hey everyone, in this video I am going to show you how to do CO Lewis structure or carbon monoxide Lewis structure, and I am also discuss the formal charge of CO, uh, the hybridization of CO, and the molecular shape or geometry of CO or carbon monoxide, and also I am gonna give you the answer of the question is carbon monoxide polar or non-polar. So let us first draw the Lewis structure of carbon monoxide. So at first we have to count the valence electron. Carbon is an element of group 4a, that is why it has 4 valence electron, and oxygen is an element of group 6a, that is why it has 6 valence electron. Basically carbon monoxide has 10 valence electrons. So how many valence electron does carbon monoxide has? The answer is 10. So this 10 valence electron has two tugs at the same time. The first tug is to connect these two atoms together, and the second tug is to satisfy the octet for all the atom. So this is carbon, this is oxygen, right? So to connect we will use two dots, right, or single bond, right? So out of 10 for connecting we have used 2, so 8 valence electron left. This 8 valence electron will be used to satisfy the octet of outer atom first. So least electronegative is carbon, so this is central atom, and oxygen is more electronegative, so this is outer atom, right? So look here, this oxygen has 2, so it can take more 2, right, more 2, more 6, right, it has 2, it can take more 6, and now you have used 6, so you have 2 valence electron left, so this will come to oxygen, come to carbon. So now you have used all the valence electron, right, 10 valence electron. Now you have to check for the octet. This oxygen has octet, but this carbon has only 4 valence electron, so we need to shift lone pair as bond pair to satisfy the octet of the central atom. So now this carbon has 2 4 6, so you have to shift more one pair. Now this carbon has 8 valence electron, and this oxygen also has 8, right? So this is the Lewis structure of carbon monoxide. So you can express this bond pair as dash, right? Now I will show you the way to find out the formal charge for any molecule, for any atoms in molecule. So let us write the formula. Formal charge equal to valence electron in neutral atom minus half of bonding electrons minus lone pairs. So for carbon, if I want to find out the valency, the formal charge of carbon in carbon monoxide, then carbon has in a neutral atom of carbon we have 4 valency electron, then half of here bonding electron, right? Bonding electron how many? Here 6, so we have to half of 6, right? Half bonding electrons minus lone pair. How many lone pair does carbon have? 2. So if you subtract 3 minus 2, that is 4 minus 5 equal to minus 1. So this carbon has minus 1 charge, right? And what about this oxygen? To find out the formal charge of oxygen, I will show you the easiest method. I think this method will be very helpful for your exam hall. Look, in a neutral atom of oxygen, how many valence electron do you get? 6. And here how many valence electron you have assigned? So 2, 3, 4, 5. That is, in case of finding formal charge, you have to consider lone pair electron totally, right? Lone pair electron totally, and you have to take a half of the bonding electrons. So plus 1. So this oxygen has plus 1 formal charge. So if you add -1 +1, then you will get 0. That is carbon monoxide molecule overall charge is 0, right? Okay. Now I will discuss about the hybridization of carbon monoxide molecule. Look, for finding hybridization, you have to know the steric number. Actually, steric number means the electron region. Look, here for central atom is oxygen. Look, oxygen for lone pair you are getting 1 electron region, and this is pi bond, this is pi bond, and this is sigma bond. In case of finding hybridization, we don't count the pi bond, right? We only count sigma bond. That is, here this lone pair represent 1 electron region, and this sigma bond, that is this portion or this sigma bond express another electron region, that is 2. So steric electron region is 2, or steric number is 2. So you need S and P, these two orbitals. That is, here carbon is sp hybridized and oxygen is also sp hybridized. So you know that sp hybridized means this carbon dioxide molecule is linear, right? Is linear. That is, the bond angle is 180 degree, right? The bond angle is 180 degree. This is linear. So can you tell me what is the molecular shape of carbon monoxide? The molecular shape or molecular geometry of carbon monoxide is linear, right? Due to sp hybridization, its shape is linear. You know that can you tell me whether carbon monoxide is polar or non-polar? Okay, let me give you the answer. Look, the electronegativity, that is the power to draw electrons, right? The electronegativity of oxygen is more than carbon. That is, oxygen is partially negative and carbon is partially positive, right? That is, this bond, due to the huge electronegativity, this bond is polar, right? This bond is polar. This bond is polar means this bond has a dipole moment, right? Dipole moment. So this bond's dipole moment does not cancel by anyone, since this is a linear molecule. So this carbon dioxide molecule must have a net molecular dipole moment, as its bond dipole moment does not cancel by anyone. Since it has dipole moment, net molecular dipole moment, so this is polar molecule. So carbon monoxide is a polar molecule.